Welcome everyone to this live panel session, Stepping Away from Fossil Fuel, Part 2. So I am Lucien Koopmans, and I'm a professor at Chalmers University of Technology in Sweden, where I'm the head of the Division of Combustion and Propulsion Systems. I also have a long history at Volvo Cars. So I will be moderating this panel discussion about the interesting presentations we've seen just now. We had some very interesting discussions in the first panel session, and I hope we'll have an even more interesting discussion in this one. So let me present the panelists. So from the first presentation, we will have with us Dr. Wisdom Enang, Design Engineering Lead ExxonMobil in Nigeria. He presented about the optimal control of HEVs, hybrid electric vehicles, with partial route preview information. So welcome, Wisdom.
Thank you very much, sir. Thank you.
And the next panelist I want to introduce is Dr. Joachim de Munk, Technical and Scientific Manager of AECC in Belgium. And he presented advanced emission control and renewable fuels for pollutants and life cycle CO2 emissions. So welcome, Joachim.
Good afternoon.
And then we have David Kunkel with us, Senior Simulation Engineer, IHI Charging Systems in Germany, who has presented real-life 95 grams CO2 per kilometer emissions from his Volkswagen Golf TGI. So welcome, David.
Hello.
And then I want to present Eric Heinecke, Chief Scientist from the Fuel Matrix from the US, who presented intermediate, achievable and profitable carbon reduction for fleet operations. Our carbon reduction strategy for 2021. So welcome, Eric.
Thank you, Luke. Good afternoon, everyone.
And finally, I want to introduce Roland Dauphin, Science Executive, Fuels Quality and Emissions, Concave, Belgium, who also was co-author of Advanced Emissions Control and Renewable Fuels for Pollutants and Life Cycle CO2 Emissions presentation that also Joachim was involved in. So welcome, Roland.
Thank you. Good afternoon.
So, the topic of this panel discussion is stepping away from fossil fuels, and I hope that we get some feedback from the listeners as well and the audience with some questions. You can chat to us, and then we will hope to incorporate this in our answers or answer them directly. Me, myself, I believe that the biggest drawback of internal combustion engines compared to battery electric vehicles are just the local emissions, actually. And I mean that LCA of CO2 can be much lower with renewable fuels compared to a BEV. But my first question is to Joachim. What's required for zero impact emissions of a internal combustion engine?
Thank you, Lucien, for the question. So indeed, I think what you raised is the topic of the discussion is about low greenhouse gas emissions and stepping away from fuels. But we clearly see the other topic, the low pollutant emissions requirement, also important for the future of the internal combustion engine. And then the question is zero impact. How low can we get these pollutant emissions? And clearly that's where the industry is working on to further reduce it. I think we should not forget we have made significant steps with the vehicles that are now going to the streets. So the Euro 6D for passenger cars, the latest stages in the Euro 6 legislation, and then also for heavy duty vehicles, the Euro 6E step, which is the last step. So significant reductions have been made thanks to the introduction of advanced emission control technologies like we showed in our presentation, and really working on integrating that those technologies within the powertrain system, because it's an integrated approach that will help us to get there. So it's working together between the engine emission control and then also the hybrid system. Further steps are possible. So let's say further integration. For sure, the future of the internal combustion engine is together with a hybrid system. So to be able to run electrically for some time, and that the electric system supports the emission control. And that's exactly also what we did in our work. So we had entry-level hybridization, so 48-volt mild hybrid. And that was not only used let's say, to reduce CO2 emissions to a certain extent, but really also to help the emission control technologies to, let's say, really reduce the pollutant emissions as much as possible. And I think what we achieved is really, you have the initial cold start peak, and then once the system is warm, you have near zero emissions when driving, even in continuous city operation. And I think then that remaining initial cold start peak, that's for sure then the further development that is ongoing to try to eliminate that as much as possible as well.
Yeah, I saw your presentation. Are there any disadvantages of using renewable fuels when it comes to local emissions?
I would say at the first stance not, because that's a bit the starting point of the work we presented, is that we achieve at least the same low pollutant emissions on these renewable fuels. But perhaps also Roland can add to that. I think of course, there's quite a range of fuels, renewable fuels that are being considered. What we did in the work was to focus on those fuels that actually we added into the vehicle without doing any modification to hardware and software. So they were we repeated tests on those fuels with the vehicle as it was, and then did not see any, let's say, negative effects on the pollutant emissions. But on the contrary, there can also be benefits. But perhaps maybe I pass on to Roland from Concawe to add a bit here to the discussion.
Yes, indeed. I could add some elements to the discussion here. What we saw in the past when using alternative fuels compared to traditional fossil fuels. So as far as diesel is concerned, this is the use of fatty acid methyl ester and hydrogenated vegetable oil. We saw in the past some effects of fuel on emissions, mostly positive on mainly particulate and NOx emissions. With the modern after-treatment systems, which Joachim has been talking about, these systems are so high in performance nowadays that we can't see any fuel effect anymore. In fact, it is deleted by the very high efficiency of these systems. And the only effect we can see right now from fuels is on the consumption of some of these after-treatment systems. For example, we see with some fuels which emit less NOx engine out, that their effect is translated into less urea consumption to reduce this NOx. But at the tailpipe, you don't see any effect anymore.
Yeah, well, that's when the after-treatment system is warm, of course. But in cold starts, for example, and then I have to talk a little bit to David. CNG, methane. Have you, because you're very interested in CNG, so have you? Can you foresee any disadvantages of methane reformation in an after-treatment system, for example, or disadvantage of biogas or whatever, gas?
Well, it's depending how good the heat up is working. I know the background. I'm not involved so much in the after treatment system, but I know about these dual lambda sensors, and I think it's important that the strategies that are made for CNG, this is not exactly the same as they use for gasoline, especially about the heat up and also the exhaust gas temperatures.
Exactly, but the legislation is similar. Roland, you had some information on Euro 7, or is there any more discussion or about renewable fuels or different approach towards renewable fuels in Euro 7?
The Euro 7, I think, is not completely decided yet. I think it's very, or in my eyes, it would be very important that if there is a bio rate within the CNG, that this would be accepted by the lawmakers. For example, in Germany, we have like 20% biogas in the net. So from the understanding, it should be that those cars get a 20% reduction rate in CO2. Already they have about 23% less CO2 when running on CNG compared to gasoline, but there should be another 20%. And in this case, I showed in my presentation, you would be at the level of electric cars of the same size.
Okay, any comment on that, Roland? Or?
Yes, if I may complete this. So Euro 7 indeed is currently being discussed in the frame of the advisory group on vehicle emission standards. Some proposals have been made. They are extremely challenging, by the way, and they now need to be assessed before the Commission makes a proposal. So this is the first part on what the future requirements will be on emissions from vehicles. And then there is the requirements on fuels. And there are several frameworks. There is a first framework, which is the Fuel Quality Directive, which will give you some constraint on fuel properties and chemical characteristics, which aim at protecting air quality. So this is the first framework. This is completed by fuel specification, so mainly concerning diesel and fuel, EN 590 and for diesel, and EN 228 for gasoline. And these aim at ensuring the good matching between the fuel and the engine. And then there is a final framework, which is the Renewable Energy Directive, which will give you the targets in terms of renewable content for the transport sector, but also for all the sectors of the economy. And this is in this framework that we will find how much renewable fuels we have to put into the pool for transport to reach our target in terms of renewability.
Okay, anyone else who wants to comment on this?
Yeah, perhaps from my side, I could also add, just to clarify that indeed Euro 7, the discussion, I would say we're still quite early in the process. So as shown in my presentation, the consortium, CLOVE consortium, so consortium of engineering houses, is looking into the topic on behalf of the European Commission since 2019, and we're expecting that their study will finish soon. But then still there is some work for the European Commission to come with their proposal, which is expected by the end of this year. And then that's when the Commission releases their proposal, that's the start of then the co-decision process between the legislative institutions, so with the Council, the Member States, and the European Parliament. So clearly, let's say the legislative process is ongoing, but still somewhat at the start in preparation of the European Commission proposal.
Yeah, I got some question on the chat from Guillaume Darding. He asks, what's your view of precious metal use in catalytic converters towards Euro 7? So, I mean, if legislation gets more stringent, maybe you need more noble metals. Wouldn't that be a problem?
So let's say there are different ways to, let's say, reduce pollutant emissions with the next steps in legislation. So increasing the amount of precious metals is perhaps what people have in mind as the most direct way to impact or to increase the conversion of systems. But yeah, as we shown in the presentation as well, it's only one part. Let's say the integration of the technologies, and then really the interplay between the different components. Also having some in close couple position, focusing on cold start, urban emissions, and then others coming in underfloor position. This interplay of components is all very important, and it's not per se that the amount of precious metals has to increase. At ACC, we don't have data on that or any projections, or that's not available. But just like to highlight, that's not the only way to increase efficiency of the system. I think what's very important going forward, and you mentioned it as well, Lucia, and the cold start phase, it's active thermal management. So it's not only getting the system heated up as quickly as possible after a cold start, but then also ensuring that if you're continuously driving around in the city, that actually your system remains hot. And that's also a bit what we did in our project, such kind of integration of the system, it's a very important factor.
Yeah, that brings me also to wisdom then, because your work with predicting driving, and you very much focused on reducing CO2 emissions. But I mean, if you have a renewable fuel, then you don't have to worry about that, right? Of the CO2 emissions. But can you refocus towards emissions?
Yeah. So although I didn't present that result in my presentation, the hybridization that we actually developed was able to get a reduction in CO2 as well as fuel consumption. Now, here's what I have to say about generally looking at it. If we look at the world, put the world in perspective, and not just Europe or America, just put the world in perspective, Africa as well. What we would see more, for example, I get the idea of the renewable energy fuel, and I also get the idea of all the benefits that also come with it. But let's talk about availability. Let's talk about the cost to people in Africa, because the objective function for an African is typically the cost. It's not. Yes, the environment is there, but the cost is overriding consideration. So hybrid electric vehicles sort of give us that in the near term, really. In the near term, so I know there's a lot of activity in Nigeria right now to go from the liquid petroleum fuel to gas, CNG, and for example, and then we're also looking at, on an individual level, a lot of people are doing some aftermarket conversion of HEVs, and to them that is something that is readily available and easy to work with based on the technical know-how around here than the renewable energy fuels, which are typically at the much in the research stage at the moment. So yes, the benefits of removing the CO2 can be achieved using either of the routes. Much more with turning to renewable energy fuels. However, we have to put in context availability of those the resources before we approach that, in whichever market we are looking at.
So you advocate moving towards CNG, or just to reduce CO2 emissions?
Yeah. So what I'm saying is, whatever solution we're going to propose is going to be market dependent. Because, for example, based on the technical know-how, the policies made, for example, in Africa, the continent isn't just ready for this massive change to renewable energy. We're not ready yet. So what is going to happen is that we would find ourselves picking geographically, just setting those standards, the transition standards and targets based on each of the regions. And what I'm saying is that in an African context, what is more plausible would be, the hybrid would be more plausible. A change to CNG will be more plausible. Renewable energy, it's going to happen, but it's going to be long term. It won't just be in the next. I don't see it happening in the next 5-10 years.
All right, Eric, would the fuel matrix be plausible in Africa?
Yeah, it would be plausible. It's ready to go anywhere, as a matter of fact. But sort of what we're hearing here is going to take an integration of a number of strategies and strategies that are market ready. And so we're looking at improvements to the fuel itself. We're looking at improvements to internal combustion processes and also after treatment systems. And the advantage of improving the fuel is that it makes combustion and the aftermarket after treatment systems more effective by reducing emissions at the source. And Fuel Matrix does that, and it also does it economically. You actually save money by using it. So from a market standpoint, it's ready to go at this point, right out the door.
Yeah, when I looked at your presentation, I saw that majority of the fuel matrix is ethanol. How would this work as well then with the renewable fuel ethanol?
We believe it will. We haven't tested it with ethanol fuel yet, and that's the value of these kind of conferences. We're looking for partners to help us mature the product with gasoline, diesel, even jet fuel. We've seen remarkable results with the product, and as was mentioned earlier, we see dramatic improvements in cold start situations as well in reducing particles.
Yeah. So, but I was just thinking, it's more like a customer benefit, right? Because how would you be able to use this one for legislation or purposes?
Well, I believe with the use of the product, yes, it'll help the customer because it saves money as well. It reduces their fuel consumption. But from a legislative standpoint, it's going to make other products more effective with the use of this product, but it reduces emissions at the combustion source.
Mm-hmm. We'll talk about customer benefits. David, CNG, you were very happy. It's cheap fuel. I got a good customer benefit on that one, especially with the gas station close by, and also you reduced CO2 emissions.
Yeah, that's the question. Why not many more people will jump on this? I think at least in Germany, if I compared the prices here, it's about 50% lower than gasoline, and about 20 to 30% lower the price compared to diesel. Of course, I showed the disadvantages, but I think the people do not know that 1 kilo of CNG holds about 1.5 liter gasoline energy. So if you look to the price tag and you see 110 and you see for gasoline 140, you say, well, it's a little bit cheaper, but you don't notice that it's just half price.
Yeah, that's interesting. The discussion in the politics. Maybe you can or Roland can comment on this one. So when do we get actually a pricing on energy content instead of liters?
This is something that is currently being discussed. How the different prices will be displayed in the retail stations. This is still work in progress, and there is an ambition to homogenize the display of the prices of the different sources. So for liquid fuels, for gaseous fuels, and for electricity as well. This is a very complex discussion, and this is still pending. So I can't tell you the outcome right now, but this is coming.
Okay.
Maybe I can add, in Germany, if you go to the store, the prices need to be printed, which, if you buy some chocolate or whatever, some meat, how much 1 kilo, 100 gram are costing. It's printed below. And I think this would be an idea to print the prices for, let's say, 10 kilowatt hours at the gas station. Then people would get aware of this cheap and fuel efficient and CO2 low fuel, like of CNG.
Yeah, well, yeah, exactly. Because at the moment it's also the other way around, right? Because here ethanol E85 is priced much lower, but you don't get so much energy out of it either. So, but yeah.
That's why I mentioned LPG. LPG looks also a much lower price, but it holds just 2/3 of a liter gasoline.
Yeah, I'd like to add to the topic, right? The one thing I'd like to say, when we're looking at pricing, we have to also factor in a government, what I would call government subsidies into some of these fields. So some of them are purposely subsidized to make sure that they encourage the use. So sometimes in some economies, it's a reflection of the actual value that is being put on these fuels. Sometimes a reflection of the the type of value it brings to the power trends, but sometimes it's just a reflection of what the governments are trying to do in terms of rolling out different fuel options.
Yeah, I got a question from the audience. Isn't diesel in the United States priced in terms of energy content, Eric? You know?
It can be. I'm not sure exactly how it's priced. I wish I knew. But primarily it's depends on local market situation, whether it's close to refinery, what are the distribution aspects, how expensive is it to get there, and then also the local taxes have a big effect on fuel prices, diesel and gas.
Yeah, here in Sweden we have a lot of HVO actually mixed with the fuel, because there is a directive from the government as well to actually mix towards the fuel manufacturers or the fuel suppliers to mix with sustainable renewable amount. And then, yeah, you tested HVO, Joachim and Roland. You didn't see any disadvantages. It's much more expensive actually if you want to buy HVO 100. What do you how do you want to motivate people to actually buy it?
Perhaps if I start on the tests itself, and then perhaps Roland, feel free to add there on in general. I think for HVO, the fact that we tested it was also not purely to focus on HVO itself. I think as what we tried to show a bit in the presentation was that by testing HVO 100%, at least we show that, let's say, without any hardware modifications to the vehicle, without any calibration change, that we got also the same results in pollutant emissions, so low pollutant emissions. And this fuel, with its paraffinic compounds, actually is then, let's say, having same characteristics or very close to the characteristics of the current fuel specifications. And then in our study, in the well-to-wheel study, we actually looked at other possibilities which also have paraffinic compounds, and then actually, yeah, we were not able to test all of them in our programs, but at least the characteristics are expected to be very similar. And so the test results we achieved on HVO represent then what can be expected from a pollutant point of view on the other fuels, like biomass to liquid is what we calculated, and also synthetic fuels like e-diesel. And it's then depending on the pathways, and I think there Roland can add much more to that. Then depending on the pathway, then you really can have the significant reductions in CO2 emissions. So by just from the test point of view, running on 100% HVO, we did not encounter any difficulty on our vehicle.
If I may complete, indeed, HVO is part of the big family of paraffinic fuels. So it may be, as Joachim said, HVO. It can be biomass to liquids. It can be power to liquids. And the big advantage of this fuel is that they are drop-in, so they are already compliant with the existing vehicle fleet. They are already compliant with the existing infrastructure, and it means that almost overnight, you may roll out this solution into the market and improve the renewability benefits of the market. You talked about the price, and indeed, this is a very important question. Renewable fuels, let's face it, are more expensive than fossil fuels, and they will remain so for a very, very long time. The reason for that is that fossil fuels have been produced by Mother Nature for hundreds of million years for free. Petroleum has been made by nature for free, and it took a very long time to do so. When you want to do renewable fuels, you need to involve human work, and human work, as you know, is not for free. So it is more costly. However, we are lucky at least in Europe, because we have a big leverage that can mitigate the price differences. And this big leverage is taxes. You probably know that in Europe, fossil fuels generally are impacted with taxes around 2/3 of the price, which means that if you take into account the renewability benefits of renewable fuels, these renewable fuels could be up to 3 times the price of fossil fuels, taxes not included, and be sold to the customer at the same price at the retail station. So there is a big leverage if you adapt the level of the taxes with the renewability benefits of the fuels, so that it can be quite invisible to the final customer in terms of prices.
Yeah, but that's in Europe then. What about the rest of the world?
So the less you have taxes, the less you have leverage. So Konkawa worked in Europe, so I won't talk about those part of the world in terms of taxes, but I can talk about other fossil fuels, such as aviation fuels and marine fuels, where the taxes are much lower. And what we see in our discussions is that it makes it way more difficult to introduce these fuels into the market, because, as I told you, as they are much more expensive when you don't have taxes, you impact the price on the customer with a very high leverage. And this makes it very painful to introduce these renewable fuels to these markets.
Yeah, I agree. This is a very difficult dilemma, actually. So does that mean that that's the end of renewable fuels? I mean, when I see renewable fuels, there are two problems, right? It's both the feedstock and it's the price. The rest, I mean, as you have indicated, I mean, you have very good efficiency and you have almost the same or similar emissions. So how do we get it? I mean, we all know that LCA, if you look at the whole picture, it's very beneficial, much beneficial, more beneficial for climate change or greenhouse than electricity with the global average. So for the human, for us, sustainability, it would be the best. So how?
So in terms of prices, our plan is to start where it is more feasible and easier to do. If you start with transport fuels, road transport fuels, where you have taxes, you know you have a leverage to equalize the prices. It allows you to scale up your processes and your facilities. So it gives you some time to let the prices go down. And then in the second step, once the prices are lower, you can go to the second part of the market, which are non-road transport fuels, so for aviation and marine. Regarding feedstock, this is a very important question. And to answer this, first question is, how much do we need? How much renewable fuel do we need? In our projections, our forecast is that in 2050 in Europe, the volume of liquid fuels that will be consumed, so the demand for liquid fuels, will be 3 times lower than it is today. So this is a huge difference, and this reduction of consumption will be enabled by huge efficiency gains, so on the powertrain, and of course electrification. So renewable fuels goes along with efficiency gains and electrification, and they are of paramount importance to enable decarbonization. With this being said, our renewable fuels will be of two kinds. Half, according to our plan in 2050, half of it will be from advanced biofuels, and the other half will be from power to fuel, approximately. Regarding the availability of feedstock, we have compared the demand that we will have to do so with reports that we have found, reports written by and for the European Commission. And this report, from our understanding, says that there is enough biofeedstock to produce these biofuels, of course, without entering competition with other sectors, such as the food industry or construction wood, for example. As it is a complex topic, we are performing further work on this to really ensure that our understanding is correct and that the availability is here. Concerning e-fuels, to ensure the scalability, you need two important things. You need decarbonized electricity, and really a lot of it, to produce green hydrogen. And you need also carbon capture and storage to capture the CO2 that will enable the production of these hydrocarbons. Concerning decarbonized electricity, today the electricity grid is not sufficiently decarbonized to allow the production of these power-to-fuels. If you did so today, in fact, these power-to-fuels would emit more CO2 than fossil fuels. So it is not time to scale up the production of these fuels. Our plan is to start scaling up around 2035, when the electricity grid in Europe will be sufficiently decarbonized, and then we will be able to scale up the production and start producing these decarbonized fuels. And so according to our projections, in 2050, the amount of fuels will be carbon neutral at the right scale.
Yeah, you were talking about, that brings me to another, because you talk about two things. There's also, you talked about the huge efficiency leap you take with the engines. That means that then you're talking about dedicated engines towards a dedicated fuel. Because with the drop-in fuels, it's business as usual, right? Or more or less. So, but with the dedicated renewable fuel, you could increase the efficiency of the engine remarkably. Brings me a little bit to hydrogen, for example. What do you think about hydrogen? That's to all of you, basically. But Roland, you're mentioning at the moment it's very costly, of course. But what about the future?
In fact, of course, drop-in fuels, when we are talking about renewable fuels, are generally more expensive than non-drop-in fuels, which can be very high rates of ethanol, or for example, fatty acid methyl ester. And there is a dilemma here, because the non-drop-in fuels are less expensive, but the time needed to roll out this solution is longer, because you need a dedicated fleet to allow more incorporation of these compounds, and you need also sometimes a dedicated infrastructure, for example, in retail stations. So there is a kind of dilemma between something that is more costly, but that you can roll out more quickly, and something that is less costly, but will take more time to roll out. Today, we don't have the unique answer to this dilemma, and we can see that the market try to work on these both legs with some dedicated solutions, with dedicated fuels and some drop-in fuels.
If I may, Roland, ask your thoughts regarding gasoline and diesel blends with renewable fuels. With limited feedstocks, that seems like that would be a strategy that would be ready to go now.
I didn't really get that. Please.
Yeah, so with limited feedstocks for renewable fuels, and we're looking to increase those and get them to the point where you can have standalone renewable fuels. In the interim, combining renewable fuels with gasoline and diesel at 5, 10, 15%, would that not be a way to get going with that quicker?
Yes, indeed, and this is the idea behind drop-in fuels. It means that you can increase the rate of renewables overnight. You can switch from 10% to 15%, 20%. And by doing so, the good thing in this is that you decarbonize the whole vehicle fleet. You don't need to change the vehicle fleet to do so. And so this is the reason why we think that increasing the rate of renewables into fuels is a very good solution to decarbonize transports, because this is something that addresses the whole vehicle fleet, indeed.
I understand that, but we want to change the fleet, right? Because we want to have much more efficient engines, which might require a specific renewable fuel, right? So
you need to do both. This is you need to work on all fronts. There is not any pathways that you can neglect. It's a very hard work.
Yeah.
Yeah, and I perhaps would like to pick up here as well that it's for any topic. I think that's a kind of general. I think all over the conference, the different panels, this topic has been addressed, like the request for a holistic approach in the regulatory framework. I think this fits a bit with what we are just saying here, that indeed it's, yeah, all solutions have to be used and will help each other, build further on each other. And often in the debates, it's a bit too much battle between this or that, this fuel versus that fuel, ICE versus battery electric vehicle, for instance. But yeah, I think just to reach our ambitious goals of net zero emissions by 2050, we will need everything, and it will also depend on the application. So, for instance, yeah, we talked a lot about passenger cars. The solutions might be different for passenger cars than for heavy duty or even maritime, and even within passenger cars, you have a range from small to higher end vehicles. And perhaps one item I wanted to ask Roland, what you just said before. You said the e-fuel, let's say, ramp up as of 2035 because of the renewable content of the electricity mix. But that's assuming a kind of relying on the average electricity mix. Is there not any possibility, let's say, to have dedicated let's say, production of renewable electricity, even as far as I understand, for instance, not within Europe, but trying, let's say, it's a global market, so trying to have sources where there's much more sunshine than in Europe, and then have these fuels produced there and being imported.
Thanks, Joachim. This is a good question, and there is no unique answer to this question. You may make the choice to say, I will install some windmills, some solar panels, and I will dedicate this to the production of e-fuels. And in this way, my electricity will be carbon neutral, and so will be my e-fuels. This is the first possibility. Another possibility is to say that, well, you can't recognize where the electron comes from. It can come from your solar panels, but it can come from anywhere in the grid. And in this case, you will say that your electricity is the result of the average grid. And this is also a valuable way of thinking. I won't discriminate any way of thinking. What is sure is that to produce e-fuels, you need a huge amount of electricity. And today, if we want to decarbonize the electricity grid, what you need to do first is to close your coal power plants. And if you want to close the coal power plants, you need to reduce the pressure on the electricity demand first, so that they can be replaced by renewables. And so if you start producing e-fuels too quickly, you will, on the contrary, increase the pressure on the electricity demand, and you will prevent this coal-fired power plant to close. So this is a first parameter to consider. Another parameter to consider is, as you have said, that you may consider imports to Europe of energy. It can be direct imports of electricity, for example, electricity produced maybe in North Africa, where it is very sunny, and then it will be transported to Europe, with some losses, of course, or directly on the place where the electricity is produced. You can produce hydrogen and import this hydrogen to Europe, but you have to know that the supply of hydrogen, transportation of hydrogen, is something extremely complex, and you have to put in place a supply chain. This is another difficulty, another issue. Or you can maybe import the final product, which means that you produce the hydrogen and you produce the power to fuel, where the electricity is also produced. One drawback of this solution is that it makes you completely dependent on your supply of energy, and that you also lose your industry in Europe, which is not good for plenty of other things, such as social well-being and jobs. So we can see that there is no unique solution. Each of them will have benefits and drawbacks. What it will be in the future, it's much too early to say.
Very interesting. I think Wisdom, I would like you to comment on this one because you do have experience also in greenfield projects. Maybe this is something.
Yeah. So, from an African perspective, what I expect to happen more is, as I said earlier, the CNG, and this is for example, Nigeria is called the giant of Africa, and just in February 2020, the Honorable Minister for State Petroleum Resources declared the decade of gas. And what that means is that there is every drive to make sure that gas is the immediate replacement for liquid fuel. So we're having three critical factors, especially in Africa. First is the prices, of course, of the value that you're going to actually get for this fuel. As one of the speakers did speak on, the petroleum fuel is produced by Mother Nature. It's just easy. It's a low-hanging fruit. We have the political system, and then we also have the economic plan. So, just to summarize, from an African perspective, CNG is definitely top on the list of the fuels that will achieve decarbonization as well as higher efficiency for the and could be used for for example with gasoline engines. I've seen configurations where we have an aftermarket kit installed, and this helps the gasoline engine to also run on on CNG. The next thing I wanted to talk on is there is some drive. I mean, it's only starting up very in its early days. There is some drive regarding the use of fuel blends. So we're having biodiesel manufacturing in some industrial scale in Nigeria, for example, and then some bits in Africa. So we're going to see that come on, and that's really where we're going to see with the three factors I listed earlier on. It's very unlikely the next 10 years renewable energy vehicles would actually be widely utilized. That's just the way I see more of, again, adding to what we've heard over and over in this conference is the need for different energy sources to work together. There isn't one solution. There isn't one which is bad and the other is better. There is need for a case-by-case solution depending on the market, depending on the kind of vehicle you're looking at, and also, just depending on the reality for each of the markets. Thank you.
Okay, thank you.
Maybe I can add to this. In Germany, the market, the electricity, it's sometimes we have such a high production of when we have enough sun and wind that we have to cut down on the electricity, and we sell this electricity to our neighbors, and we sometimes even pay them to take our electricity. And I know from Audi, they have a plant where they produce e-gas when there's an overshoot of electricity in the German net. And I think this would be a solution. They make e-gas, they put this in the gas net, and it can be stored right away. Of course, this plant somewhere in northern Germany is running a very low time of hours, but still this would be a way of saving electricity when we have an overshoot.
I got a question from comment from Francis from the Sluis. Why in Africa not use the potential of the Sahara?
Okay, right. So that's a good point, and one that I'm willing to take back and just pitch to some of the government people.
I think we lost your voice, Wisdom, so I'm sorry for that. Yeah, I think. Yeah, something went wrong technically. Okay, it doesn't
Okay,
matter.
sorry. It did.
Oh, now you're back. Actually, you're back.
Okay,
Okay.
right. So, just to answer, there is that potential. It hasn't been explored yet. Again, just looking, the source of energy we explore in Nigeria, for example, is just driven by what's readily available. For example, we have a lot of gas flaring that's going on right now. The way we're tackling this is by putting out a lot of fines, and and we've even recently increased the fine for companies to pay. So that tells you that there's this abundance of resources when it comes to gas to drive the production of electricity. So that puts very much on the value chain other avenues to getting electricity, for example. Again, it is something to consider and wait, and I'm willing to take that back to the to the government stakeholders.
All right. I was just wondering also, David, to when you talk about gas, what would you do? Would you use if you have biogas, for example? Would you use it directly, or would you use steam methane reforming with carbon capturing and using the hydrogen instead?
Well, of course, if you have the e-gas, you can use this right away in the car. In the hydrogen, of course, the losses to get from electricity to hydrogen are lower, but the point is, where do you store the hydrogen? The hydrogen has to be stored separately, at least in the German gas net. I think up to 2% of hydrogen can be stored, but you have this gas net of methane already installed. We have such a huge capacity to store energy within gas. So I would be I would suggest to have this as e-gas, just included in the gas net in Germany.
Okay, thank you very much. I think we are very close. We are about 10 minutes left, so I would like everybody to give the opportunity to comment or ask some questions. Eric?
Well, I think a lot of new technologies, long-term solutions, they're all very important, but for the short term, I think the quickest way to make a big impact is with existing fuels and fuel blends and fuel technologies that can utilize existing infrastructure and not require engine modifications, that sort of thing. They're basically drop-in ready to improve combustion and reduce emissions right out of the gate and have an immediate impact.
Thank you.
Yeah, Lucia, maybe I would begin on that one, that indeed, let's say, especially with legislation focusing on new technology coming to the market, it's a very important part of the story. But I think for the reduction of CO2 emissions of transport, a lot can be done with the existing fleet with drop-in capabilities of renewable fuels, and perhaps that's exactly, let's say, how to get more of these fuels on the market. It's to have a framework that supports that, and that can have a direct benefit, and then our goal is to reduce the CO2 emissions of transport as a whole. So the more you can do on the existing fleet, and the more emissions will be reduced. If we only focus on the new vehicles, it's only with fleet turnover, etc., that it takes time to have that effect. With drop-in fuels, it's immediately there.
Yeah, I totally agree. It's very, yeah. Roland?
Yes, I can only add to this that obtaining a carbon neutral transport will be extremely challenging. This is probably one of the biggest challenges we have ever faced. Of course, in doing this, having a good electrification of the fleet with renewable electricity will be of a very high importance, and we really rely on this. However, we also think that it will be very hard to electrify everything, that there will be remaining parts, especially in heavy duty, where it will be too challenging to electrify the transport. And this is where renewable fuels are extremely important, because they will allow to decarbonize this remaining part of the fleet and really obtain a carbon neutral transport.
Yeah. David, any last comments?
Well, I think if the European Union or the German government would accept like biogas is a zero CO2 fuel, and like now what we have, electric cars in Germany currently get 9,000 euro. They are subsidized if you buy an electric car. Let's say if a CNG car was subsidized by 9,000 euro, there would probably be a lot more people to buy such a car and to use this fuel. And especially those gas stations, and in the meantime we have about 50% of the gas stations offering 100% biogas, then, or 100%, I'm not sure, but biogas, then it would make a huge step forward towards this fuel.
Thank you. Wisdom, any last comments?
Oh yeah. So my perspective, right, the development of renewable energy or cleaner energy sources, really, I won't pick on either of them, must be driven by the economic.
Oh, we lost you again. Actually, I'm very sorry. Yeah, I think you're still not there. Sorry. Okay. Well, I think we had a very nice discussion.
Can you hear me?
Yeah, now we hear you again. Okay, you can finish. Please finish. Some technical problems in the end here. No, it's not working. I'm sorry for that, Wisdom. But what you can do, you can still use the chat afterwards, as I understood. So, yeah, I think, okay, you can speak. Then, yeah, I think, thank you very much for this panel discussion. It was an interesting discussion. And I hope that you enjoyed it too. And then I hope that we meet each other again somewhere in the future.
Thank you.
Thank you.
Thank you very much.
Thank you.